So this video is meant to be a review of oxidation reduction reactions. You've already had this topic in General Chemistry 1, and you can click on that lesson if you want to go back and review it in more detail. The biggest thing that's unique about oxidation reduction reactions is that we write them as two separate reactions, but they actually aren't. So in the top reaction, we have electrons that are being released. Whenever we write something as a product, it's kind of like it's being released. And over here, these electrons are then the electrons, this set. Those are these electrons. They're the ones that then react with the zinc to make zinc with a zero oxidation state. So even though you see 2 electrons and 2 electrons in this reaction, it's not 4. It's the same 2 reactions. It's the same 2 electrons, and the reactions actually combine and work together. So that's the first thing to recognize. The second thing is that with oxidation numbers and understanding oxidation numbers, it kind of helps you see what's going on. Remember that an element by itself has an oxidation number of 0. And so you can see that this one is going from 0 to +2. It's becoming more positive. And you can see that this one is going from zinc +2 to 0. So this is becoming more negative, or it's reducing. So what we really have here is something that's called an oxidation. And so whenever you have something becoming more positive, that's going to be your oxidation. And then you have to have both in a reaction, just like the electrons are being used in the other reaction. So you have to have both. So this one would be your reduction. But like I said, you combine them and you write them together. We split them apart so we can see who's losing the electron and who's gaining. This can affect electron flow on wires, which corresponds to talking about batteries, which is where we're headed with all of this information. So we do need to know where the electrons are coming from and where they're going to get the poles of our battery working correctly. Last little thing is that we do have another word that we use when we're talking about these, and it's a weird word because it flips what you're talking about. So this is oxidation, but you also have an agent that causes the other thing to happen, and so they flip the word. They actually call this a reducing agent, and then we call the other one an oxidizing agent. So the reducing agent is what causes the other compound to reduce. It's weird. And then this is the oxidizing agent, and it's the one that causes the first reaction to oxidize. So that's how that terminology is working. I recommend just using one set. When I was in school, I learned this set with just oxidation reduction. And then I just flip the word when I'm talking about the agent. And I also recognize that the agent is always going to be the reactant that's doing something.